Hello, friends. Welcome to another episode of On dotnet Live. I'm excited. That music puts me in a good mood for a Monday morning. So, welcome everyone to 60 minutes of unscripted .NET entertainment. Our mission is to empower the .NET community to achieve more. So, I'm your host, Maira Wenzel, with my co-host for the day, David Pine and Cecil Phillip. And I'd like to welcome today's guest, Jody Donetti. He's going to be
Hi.
talking. Hello. He's going to be talking to us about caching and also his open source project Fusion Cache, right?
Fusion
Yep.
Cache, yep.
Yeah. And so how about you introduce yourself, Jody?
Yeah. Hi, everyone. First of all, thanks for to be here. My name is Jody, and I'm doing mostly web stuff for like almost 30 years now. So it's been a lot. And yeah, I have to dealt with a lot of caching in my career. So I decided to come up with this project to help other people that the same issues as me.
You just casually dropped that you've been doing development for 30 years.
Yeah, it's been a
That's
lot.
amazing.
Yeah.
Kudos. That's awesome.
Thank you.
Awesome. Yeah. And so caching is such a necessary tool in our developer toolbox. And I'm super curious to see what you're going to be talking about. I think you're going to be covering some of the best practices and some of the like real world scenarios. Do you want to bring it? Do you want us to bring up your presentation up?
Yeah, sure. So here it is. I'm not seeing the share screen anymore. Can I go?
Yeah.
Yeah.
It's
Okay,
sharing,
great.
Great.
So yeah, so every cache painting. Basically, hi, I'm Jody. As I said, I'm doing stuff for 30 years, and I dealt with a lot of different type of caches along the years, and that allowed me to have some experiences with different types like memory distributed HTTP caching, CDNs, offline, etc. I've been lucky enough a couple of years ago to receive a Google Open Source Award for my work on FusionCache, and the next year an MVP award. So that's great. So FusionCache is basically what I created, again, 3 years ago now, to be able to share with the community the lessons that I've learned regarding caching in my career. And as a lot of people, I've used open source software a lot along the years, but then I've never felt like I contributed back enough. So yeah, I decided to take the plunge and come up with my own project. Currently, it sits at around 3.2 million downloads, the entire packages, and the main one is about 1.4 million. So it's going quite well, and it's mid-licensed. So just a quick overview, and then we can deal with the concrete stuff, the actual useful stuff. FusionCache is based on the two core abstractions in .NET. So iMemory cache and iDistributed cache. It supports dependency injection with a builder, so you can configure stuff at the beginning at setup time. It is fully sync and async, meaning not sync over async or something like that. It's fully implemented in both ways to get the best of our performance. It supports options, a wide array of options, both global and granular with smart defaults. It supports multiple named caches, cancellation, the cancellation token, the user one, logging via logger, full observability with open telemetry. It has a rich, I have to say, documentation directly on the GitHub repo. And also it has full XML document. So while you type and you're trying to discover to see if it fits you or not, you can understand each method and option, what it does. It's MIT licensed and it targets .NET Standard 2.0, meaning it will run everywhere, both the old .NET framework, .NET Core, the new one, everywhere. And basically, this is the gist of it. Like these are three main methods, get or set, pretty usual in caching solutions, where you can say, give me back the data that is in the cache for this cache key. And if it's not there, go grab it from the database or whatever it is with a Lambda. And you can pass some options. The other one is set, which is I already have the data. I just want to put it into the cache, but it's pretty similar. But it can show a different way of setting options. You can start from the default ones that you can set globally to not repeat yourself every single call. And then you can play with some with a fluent interface to change a little bit what you want in this specific call. And the last one is an example of try to get something from the cache and tells me if it's there or not, and if it's there, what is the value in a very explicit way to avoid confusing null, the usual thing used by a lot of solutions out there in the cache world, which you can confuse null. Is it null in the cache or it is not there? So this is an explicit way to avoid it.
I do have a question real quick, Jody, if I might interject.
Oh, yeah, absolutely.
If you could go back to the previous slide, I'm curious, like the get or set.
Yep.
Do you have any sort of like guarantee with the second parameter that appears to be like a factory that would go get the product from the database to ensure that that is only hit once if there is something? Like how do you handle essentially like race conditions? Like
Yeah. You're talking about what is called in the caching world as cache stampede, which is basically 1,000 requests for product 1, 2, 3. All of them will go to database. And yes, this is a spoiler for the next slides, but yes, it protects you automatically for cache stampede.
Awesome, perfect.
Yeah.
Okay.
Okay, but good point. It's one of the first things. It will be a very practical like presentation, but just one slide theoretical, meaning I would like to make a straight point on what it means to cache, because a lot of people, I tend to see in my career, people not using cache because it's a copy of the original data, it's not the same, or on the other side, they have problems and they slap caching on top without thinking too much. Caching means accepting a compromise, which is not a bad thing. Is using explicitly a copy of the original data that may be potentially, but not necessarily, not frequently, not updated in exchange for a lot of performance and robustness. We have to keep this in mind. And by the way, this is what already happens in a way when you ask something to the database, because when the database engine puts something to the network, it's already a copy. So we just extend a little bit the wide of the reach of the data that we are using. With that in mind, how important it is, because again, some people say, I don't care caching. Well, caching is at the foundation of the web since 1990, the very first HTTP 1.0 standard. So first as a pragma header, then as a cache control, then multiple extensions like etags, stale or validate. I mean, without caching, the web would not exist. So it's very important, and I suggest everybody to be familiar with it. And hopefully with FusionCache it will be easier, but we'll see. So concrete problems. I would like to give some examples of problems and how to solve them for the real world. So the first is cache stampede, the thing you were talking about. So imagine we have a lot of requests for the same data, okay? Normally, without any special care, all of these requests will check the cache, see the data is not there, and all will go to the database and then save the data to the cache. But this is a waste, because if they happen at the same time, I mean, you can only go one, right? It would be way better. And this is what FusionCache does. By simply using a single call to get or set instead of two separate calls, which is typically what people do, like get, then if null check, and then a set. With get or set, we are automatically protected from cache stampede without doing anything else. One thing to notice is that there's a similar method in memory cache in the framework, which is called get or create. And sometimes I saw people thinking, well, I'm okay, I use get or create, but no, that does not protect you from cache stampede. So it's something to keep in mind.
That's why I asked, because I'm familiar with the memory cache implementation, and I knew it was, okay, perfect, great.
Yeah. And it's quite complicated inside how to deal with that, but in the different situations, but yeah, it's there. So this is the end result, basically. Two different requests, multiple requests for two pieces of data. Both of them will go to the database, but one for each single piece of data. This is important because I would like to highlight that asking for product 1 will not block the request for product 2, so they will go in parallel. But for product 1, only once. There's another common problem. Sometimes, things fail and the database is down or is up and running, but there's a network connectivity issue, something like that. And when the database fails and the data in the cache is expired, it's gone for good. So when that happens, you will receive an exception from the database, which will translate to an exception to your own end users. But getting back to the initial statements of the compromise, we're using copy the data. Well, if you cache something for 1 minute and it is expired from 1 minute and 1 second, wouldn't it be okay, after all, to reuse that old piece of data in case of a problem with the data source? That's actually what failsafe does. Failsafe is a mechanism in FusionCache where you can just enable it and you're good to go. Just set failsafe true and end of story. And what it does is we'll keep around expired data for a little bit longer so that it can be reused in case of the refresh going bananas. So the database is down, what can I do? Well, it's okay, reuse the old value temporarily. The two parameters that we can see on screen here, the time span parameters, are the so-called failsafe throttle duration and max duration. The throttle is how much time should a cached value that is expired be considered okay again before retrying to go to the database. And usually it's a small value, like 5 seconds, 30 seconds, whatever, so that you will get, again, another retry on the database. The second is the max duration, which is, okay, cool, you do this dance of repeating and retrying, cool. But after like a day or an hour, whatever it's in your scenario, it may be just too much. I would prefer an exception, and I will deal with that, okay? So you can configure both one or the other. It helps a lot against DDoS attacks. In particular, I cannot go into the details because NDAs and whatever, but I can tell you that in a project where we were using FusionCache, it helped us a lot. It helped us sustain something like more than 20 DDoS attacks in the span of a couple of months, including 2, which were kind of amazing, I have to say. One lasted 24 hours, and it gave us 450 times, not percent, times the normal peak traffic in a day. So imagine your website doing 1 million page views in a day. Cool. Now you have 450 million of that. Wow. It's a lot. Yeah. I mean, it was not just failsafe and FusionCache. It was a CDN with a lot of moving parts that protected us, but failsafe paid a lot of effort into that. And the second one lasted only 10 minutes, but boy, oh boy, in 10 minutes, we received 1.2 thousand times the normal peak traffic. So again, wow. 1 million requests, now you have 1.2 billion requests in the same amount of time. So it was a lot.
That is awesome. We do have our first question coming in.
Oh, yeah.
Not that it necessarily directly relates to fail-safes, but Isaac from YouTube is asking, like, what kind of performance improvements can be expected by integrating FusionCache into a .NET app?
Well, it depends on how your database performs and stuff like that. But in general, I saw people asking me, hey, I'm using FusionCache, super cool, thank you. We saw like 50% reductions of the database calls just by using FusionCache.
Wow.
Yeah, I mean, I don't know, for some maybe 10%, for some maybe 60, but I mean, it will be a lot less calls to the database because of the cache stampede prevention and other things that we'll see. And then the cache is in memory, but with a trick that we'll see later. So yeah, a lot of performance improvements.
And is the scenario for FusionCache to be like related to database data?
Sorry, again?
The FusionCache, is that like primarily the use case is for database connections and access?
Well, actually, no. You can use it with whatever data source you want. I've used it personally with database mainly, but also with remote services. When you have something like, for example, a headless CMS, for example, which exposes data through a REST API or GraphQL API or whatever, you can use that. You can use it whenever there's data somewhere else that you need to fetch. And before moving on, the name is also an homage. The name of the feature is also an homage to a movie by Sidney Lumet, which I suggest everybody to look because it's quite old but very, very, very beautiful. Anyways,
Well, I was gonna say we do have actually a related question to fail-safes. Okay. Danny from YouTube is curious, like, how does the fail-safe help against the DDoS? Like, what specifically about it helped with the denial of service?
Basically, when there's a DDoS, some calls will slip through anyway. So that will increment the load on your database. And in that case, sometimes you will have the database going down or be very slow to respond up to a timeout, usual timeout of a DB connection or whatever. And in that case, the database will fail. And when it fails, being able to just reuse temporarily the old cached value instead of just exploding everything, it's a godsend. Yeah, that's basically it. And there's another feature that we'll see in a moment that will help against DDoS attacks or similar, and we'll see it in a moment. This is the database failure scenario after, meaning an exception on the database will reach your service, but then the end user will see all good. There's another problem though. Sometimes the database, the world is not just on and off. The world is a shade of gray. So in case the database is up and running, but it's overloaded, it may respond, but very slowly. So imagine your database answering in like 5 milliseconds normally, 10 milliseconds, whatever, and suddenly goes to 1 second, 10 seconds, something like that. Now, what usually happens is that, again, your service will become slow to respond to your users. And this is what normally happens on the screen. We have our call that goes to FusionCache. It will check the cache. Let's say it's not there or it's expired. It will call the factory that goes to the database. And at the end, it will save the data into the cache and respond. So when the call is done and when the new value is available are aligned in time. But maybe we can think about fail-safe and say, yeah, you know what? Even if the database is up and running, but it's very low to answer, I would like to temporarily reuse the stale value that we talked about before. And this is what factory timeouts put to the table. This is another feature of FusionCache where you can have both soft and hard timeouts. Soft is when you have a fallback value, so an expired value to reuse, and hard is when you don't have anything. And the nice thing is that you can simply say set factory timeouts, like in this example, 100 milliseconds. And that means that every time there's a refresh, after 100 milliseconds, if the database call or whatever it is not back with a new value, FusionCache will temporarily reuse the stale value, put it into the cache again, like with failsafe, and then keep running the connection to the database in the background. So there will not be a waste of resources, so to speak, because as soon as it will finish, it will automatically save the data into the cache so that it will be available for every other request that is pending or that will come. This is like getting the best of both worlds because you have a very fast response most of the times and fresh data updated as soon as possible. Background factory completion, the below note, is this mechanism of putting a factory that is running in the background. And the other note is, which may seem counterintuitive at first, is that it can help your SEO if you have a public-facing website. Because what we noticed in production on a website with like millions of users per day was that by simply enabling factory timeouts, we saw way less spikes in the time there was a refresh on the database, because again, it will flatten the duration, the response times. And that in turn will make better time to first byte, larger contentful paint, or core web vitals in general. And that will boost your position in the search results, which is great and basically for free. So this is the end result. So what we saw before, right now we can see that after a certain amount of time, in this case, like 100 milliseconds, the old data will be saved into the cache and the call will be done. So the response of your service will be faster. The factory will keep running in the background, and when done, we'll save the data into the cache, and we have decoupled when the call is done and when the new value is available, getting the best of both worlds again. A different approach of soft timeout is called eager refresh. So it is possible to say, hey, you know what? Cache this data for, say, a minute, like in this case, but after 90% of this minute, if a request comes in, serve the data as normally, like it's a fresh data, it's not expired, so it's good. But at the same time, start a background non-blocking refresh that will start updating the data in the background through the database or whatever. And so that it will be most probable that the data is already updated when the expire time hit, okay? So it's a different way to handle the same thing. Now, one question can be, okay, which one should I use? Whatever you prefer, one, the other, or both, because eager refresh protects you from slow calls before the expiration, whereas soft timeout protects you from after the expiration occurs. So you can be protected from both. And just a couple of notes at the bottom saying that 80%, so 0.8, is generally a good value. Don't go too low, because if you say 10%, it means that after 10% of the duration, start immediately going to the database and refresh the data. It will be a continuous refresh cycle.
We do have several questions coming in. I'm going to put one up here. One's from our peer on the .NET team, Ruben Bond, who's asking, is there a way to tell the cache to evict entries more aggressively when the app is under memory pressure? Which I think is a very intriguing question.
Not automatically, because there's no from the memory cache in respect of the old, I think it was called like object cache or something. There's no way to precisely control the amount of memory allocated and how much it is consuming and stuff like that. Having said that, it uses FusionCache underneath uses memory cache. So if there's the size, for example, attribute, which is used in the new memory cache, if you use that, that will work because underneath there's memory cache. So it will be automatically supported. Yeah.
Awesome.
So I have a quick question then,
Yep.
kind of piggybacking on Ruben's question really quick. And as I was digging through your GitHub repo, I saw that there's OpenTelemetry support. And I was actually going to say this question until later, but if using OpenTelemetry, is it possible to inspect the metrics and then change the behavior based on the metrics that you consume to have it then, I don't know, change that caching policy? Is that a thing that's possible?
That's interesting.
I will say yeah. I haven't done that yet, but yes, because you can use I will say maybe a custom collector for OpenTelemetry, which does not collect data but just process that and use that to then drive some calls to FusionCache, like expire calls or stuff like that. So you can do that. Another way that will not even require OpenTelemetry, which is a little bit heavier to support, is the use of events, because FusionCache supports also events. So you can take a look at when something is expired, is set or get, stuff like that. Cache hits, so you can play with that and do LRU policies or stuff like that. It's possible, yeah.
Okay, so then it would be possible after my application is started that I could go back in and retroactively update the caching settings. It's not one of those things that like I have to set it up on app boot and then I can't change it again, right? Like I can change this anytime I wanted to. Is that what we're saying?
I'm thinking the options for each call. The option can be specified for each call. Okay. So if you have some options saved somewhere like a singleton or whatever you want, you can change that and immediately would be reflected. So if that is the question. Yeah. Okay. One other small thing is that sometimes, as we saw, we can specify very granularly for each call some options. Okay. The problem is that sometimes these options, like for example, the duration is the typical example, changes not based on the type of data, but on the instance of data itself. For example, a news article, say you have a newspaper website, a very old article that has been updated last time like 2 years ago, maybe it's okay to cache it for like 1 hour or 30 minutes or whatever. But something that is just being published, maybe there will be a typo, some changes will be quicker to update that, and you want to change the duration based on the specific news article. Another example is out token, which may last differently based on the type of token that is being minted, or HTTP response. But one question will be, well, when I make the call, I have to specify the options, but it's inside of the factory that I know the object itself. How can I do that? Well, there's adaptive caching. Now, basically it means that you just use a different overload, in this case, one with 2 parameters for the factory, so context and underscore. In this case, underscore is the cancellation token. And in this case, you can go to the database, grab the piece of data, and then decide what to do. And as we see here in the first if product is null, we can change via context.options. We can change the duration, priority, size, whatever we want. So we can adapt the cache options based on the specific instance, which is nice. So in this case, what I'm doing is, if there's nothing in the database, I will cache it for 5 minutes. If it's the last update in the last day, cache it for 1 minute, because maybe typos, updates, or whatever. And otherwise, 30 minutes is fine. This is very important to differentiate each single object's specific options. And here I kept the title in Italian because it's an homage to a movie, to the leopard in American. It's the gattopardo in Italian. Tutto cambia perché nulla cambia. It means basically translate to everything changes, so nothing will change. But long story short, sometimes you have a piece of data that comes from the source, like a database or remote web service, that is very important to react to the change of it, but usually will change not that frequently. So in that case, what you usually end up doing is I will put this piece of data in the cache for like 1 minute, and every minute I will go and grab the new version. The problem is that sometimes it's maybe like, I don't know, 100 kilobytes of JSON or something like that. And it's a waste to keep getting back the same data every single time. Would it be nice if the source will have a way to tell us, hey, the version you have, it's cool, nothing has changed, and can prevent the source from sending the data. In the HTTP world, they solved it like years ago, decades ago, with conditional request. And in FusionCache, I added the conditional refresh. Basically, it's the same thing, and it can use conditional request on the HTTP stack. And basically, it's a way to say, make a request, but if you see, like we see here in the sample, if we see that there's a cached value in FusionCache, and it has an e tag, for example, which is a standard mechanism in the web, I will add if non-match header to the request I'm doing. Then I send the request. I make sure that the status code is successful. If not, throws an exception, so fail safe, blah, 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 everything we saw. And then if the status code is not modified, it means that the server is telling me, hey, what you have is already good. So I simply say return context not modified. And this in turn will tell FusionCache, hey, what you have, it's still good. Refresh it, keep it fresh for another duration amount. Otherwise, I can say simply context.modified with a return, and then deserialize the object, the product in this case in JSON, and then specify the e tag so that the dance will go the same thing the next cycle, let's say. This is important. This will have the best of both worlds again, because you will have every minute potential in your data, but if nothing changes, no waste of bandwidth, no waste of resources in deserializing the same data all over again, no push on the garbage collection, no nothing.
That's super cool.
Yeah.
Go ahead.
Oh, okay. Another common problem.
We do. I wanted to take a pause because we do have some questions that are piling up that we want to make sure that we get to it as well. It's not super related to conditional refresh, but so one was from Dima. Does it really make sense to implement such a cache for medium-sized apps like database may cache data in memory in case it's fetched frequently? Or you can use memory optimized tables to do this.
Memory optimized table, meaning, I don't know if he's referring to memory tables inside of SQL Server, for example, but that's like on the server side anyway. So you have to pay the bandwidth and deserialization. To me, I have to say that using caching, even just in memory, it's usually it's okay. Maybe use a small duration just so if you don't update it that frequently, it will not be a problem. You will not have server stale data for too much time. But I would say yes, because I worked on big websites, but also very small. And even in them, I use the caching all the time because it's you will see the CPU on your website going very, very small. I had like, for example, a website with millions of users per day, which was like, let's say 80% read and 20% writes. And it was up and running with like one web server with like 2 cores and like, I think 16 gigs of RAM or maybe 8, I don't remember. No, 8 gigs of RAM. So, and the CPU was always constantly at like 5% thanks to caching. So yeah, I would suggest it's cost saving on the cloud. That's something to keep in mind.
Yeah, that's for sure. I think that the cost advantage, and also it's like not the size of the app itself, right? But like how much, like how many users will consuming, how much performance is important for you, and like how much, like if it's like global, being accessed from different parts of the globe. So I think it's like people should consider those things instead of like how large is the app, because like if we think about like I manage the .NET website, is like not a huge application per se. It's like not a huge project, but it's like important to have like the best performance, things like that. And caching is important in that scenario.
Yeah. Even small amount of users, when somebody asks for a page and the cache is expired, you will have to wait for the database, etc. So the network calls, and I mean, there's this thing called the fallacies of distributed computing, which I suggest everybody to read. This is a very small page on Wikipedia, but basically, network has like a lot of potential issues. Normally, stuff goes well, but sometimes not so much. So it will ease even that scenario. Yeah. Another common problem in the caching world is called cold start. And basically it happens when at every restart of your application. So the cache is empty, okay? So when that happens, it needs to be repopulated, but that means more requests to the database, okay? So there's something to look at and potentially solve. Now, a similar but different problem, or at least in the same ballpark, is scalability, meaning you can scale vertically, make your server bigger, but after a certain amount of time, you need to scale horizontally, meaning you have to have more nodes. And when you have more nodes, the memory cache in each node may have the same data, and you need to go grab it from the database from every node, okay? And this is kind of a waste because, I mean, product 1, 2, 3 is the same at this moment in time. So it would be cool to share this data with different nodes in a way, or at least do not go to database every single time. Now, some of the viewers may be thinking, I know where it's going, distributed cache. Yes and no, meaning if you want to use a distributed cache instead of a memory cache, not so fast, because memory cache has some cons on top of having some pros. But the same is true for distributed cache. For example, memory cache has an incredible data locality. The data is in the same memory, but like not just in memory, in the same memory space of the application that is using it. It is a direct instance, meaning the objects are actually the same because underneath, spoiler, every memory cache is a dictionary plus an expiration slapped on top of it. And it's always there, okay, unless we talk about like solar flares, but it's always there. Whereas a distributed cache, it is a different beast. It's behind the network. So there's network latency, there's the deserialization cost, because basically it's like a byte array that you receive and you have to deserialize. And then there may be availability problems. So using distributed cache instead of a memory cache, I wouldn't say so. Some solutions I saw around are using distributed cache and having a memory cache as a fallback, which seems nice at first, but then you have to think that, again, you're paying network and deserialization every single call. So maybe not the best solution. You cannot beat an object accessing memory. So in FusionCache, what you can do, you can enable a second level, which is distributed. Any implementation existing on the world and whatever you can come up with of iDistributed cache works transparently. So Redis, Memcache, SQLite even for mobile application, that's a use they've been told me they've used it with FusionCache. And the cool thing is that you do not have to change a single line of code in your existing code, each get or set, remove, expire, whatever calls. You just have to change one line, 2 lines actually in the setup phase. So when you register FusionCache in the I or manually, you just have to specify a serializer and an implementation of iDistributed cache. All the dance between the 2 layers, checking one, then the other, then updating one or the other, stuff like that, all is taken care of by FusionCache. So basically, it's transparent. You have your code with the memory cache, drop 2 additional lines, and you have a distributed cache, which can share the data between different nodes, okay? Case in point, the serializer, there's no iSerializer interface in .NET. So what I had to do is I created an iFusionCache serializer interface, which is very simple. It's just an adapter towards any kind of serializer existing. And then I made the implementation available for in the repo as a NuGet package for the most common ones, System.text.json, JSON.NET, Protobuf, Memory Pack, Message Pack, the usual suspects, so to speak. So yeah, 2 lines, and you will have automatically distributed cache as a second level. There's a little problem though, because now when something is not in the memory cache, we may find it on the distributed cache populated by another node, so it's cool. But what happens when another node updates the data? Well, it typically updates its own memory cache. It will update the distributed cache. But if that piece of data is in another node already cached in memory for, let's say, 1 minute, until it will expire, it will not change. So you may have problems like synchronization issues, okay? This is what I'm talking about. Basically, you get one version of the data from one node and one version from another. And if you have sticky routing, you can maybe limit that. So the same user will go to the same node every time. But then I will see data and you will see, maybe another user will see another version of the data. And it's not fine. Luckily, FusionCache helps us there too, because this is what's called the backplane. And with one additional line of configuration, again, at the setup, without changing anything in your existing code, you can enable a backplane, which basically is a lightweight message bus, a PubSub mechanism that basically send messages to all the other nodes in case something needs to be updated. Okay, so when you update something on a node, it will say to the others, hey, look, this thing is changed, do your thing. It will not send the payload, the object itself, because it may be a waste. Maybe nobody else has that piece of data in their memory cache, so it's not needed. And what it does is when it receives the message on another node, it will check the memory cache. And if it's there, it may update it or even just expire it based on some heuristics. And if it's not there, nothing will be done. So very optimized. And again, these will take care of all the communications between all the nodes with just one line in the setup. So pretty nice. Hic sunt draconis. So I wouldn't go too much into details, but let's say that you have everything right. You set up your FusionCache, your distributed level, your memory level, the backplane, and everything is fine and perfectly happy. Until you have some transient issues, which happens sometimes all the time. Sometimes when you're on Black Friday and you're suffering some, some sales. Yeah. And what happens when something gets updated on a node, a message is sent via backplane, but is lost because maybe the backplane is down, or maybe you are trying to update the distributed cache, but heck, is down, Redis instance is down, or it's up and running, but it's not reachable because the topology change in the network or whatever. And that is a problem because you will have basically an issue of out of sync, again, because of a missed message or a missed update. So it would be nice, again, if FusionCache get us some sort of a solution to that without having to think about it too much because it's quite complex. And here it is, auto recovery. Auto recovery basically is a feature that handles all of these kinds of distributed transient errors. Basically, it understands that there's been a problem in the distributed cache and or the backplane. And in that case, it will retry in a delayed fashion. But not just that, when time comes for a retry, it will first check to see if the thing is still valid. Meaning, if a node is disconnected from a Redis instance, a shared Redis instance, for like a minute, when it gets back and will try to send it again, maybe it is trying to send an update that it has been already overrode by another node that has been able to update the Redis cache. So what it does is use some heuristics to see, okay, is it still needed? Or maybe not. Maybe somebody else updated the distributed cache and I missed that because I was disconnected. So in that case, I am the node who should stop sending this backplane message and update the distributed cache and get new value. But only if I have that value in my local cache, because maybe it's not there anymore and I don't need it. So all of these things, all automatically taken care of for you with just basically no lines of code. The screenshot is not broken. It's just that you don't need to do anything. It's auto enabled by default.
I'm happy you said that because I was thinking to myself, wait a second, where's the code for the auto recovery feature?
Yeah, it's here. Yeah, you don't have to do anything. Yeah.
Well, so what haven't you thought of? I feel like this is a pretty feature complete set, like that you don't ever have to touch again.
There are a couple of things that it's my backlog, and maybe for the next version, I keep working on that. It's like 3 years now, but I have some, niche things or some more advanced stuff. You'll see.
Awesome.
And we'll see a demo in a minute.
Okay.
Now, very quickly, I'm about to finish. Way to slow down, meaning, okay, oh, cool, so awesome. But when something bad actually happens, and you'll see, because in the end, maybe something actually slowed down or something, I would like to understand. And what usually happens is like, I need to see some logs or stuff like that. And here we can see about OpenTelemetry that we spoke about before, meaning FusionCache from the couple of versions ago have full support for observability, meaning both logs via iLogger interface, but also OpenTelemetry, so traces and metrics, okay? So in the usual way in .NET with which we can set up OpenTelemetry with tracing and with metrics with these calls, we just have a nice little extension method called add FusionCache instrumentation, both for traces and metrics. This is the one without options with the defaults, but you can also specify some options where you can enable like the distributed level tracing or just the memory or whatever you can configure. And this is it, really. With one line of code, you can have distributed tracing. And if you use something like, for example, Jaeger, Prometheus, Onicon, whatever service or tool you want to use. This is the end result. And I have to tell you, working on FusionCache for years and finally being able to see with my eyes this diagram, this flowchart, not flowchart, this waterfall chart has been amazing, because here I can clearly see what happened in a very quick way. So when when something bad happens, being able to look at this and see, oh, I see, the factory ran for like 2 seconds, like in this case. But as we see, in this case, we enabled, for example, soft timeout after a second. So what happened is that check on the memory cache, check on the memory cache again after getting the lock for cache stampede protection, check on the distributed cache, nothing is there. Call the factory. After 1 second, there's this little circle here that means here is a screenshot, but it is interactive in the UI of the application that you pick. It says the factory has been moved to a background thread, okay? So then there's a little save in the memory cache to renew temporarily the old data, and then the method call returns after a second or a little bit more. But then the factory goes on, and when it finishes, it will update the memory cache, update the distributed cache, and send a message to the backplane. And it's clearly seen in front of my eyes, and again, the first time I saw it, it was like, oh, finally I can see it. So it's really cool.
Yeah, I absolutely love this feature. Yeah. And not only that, like I love the way that you've obviously implemented it, right? Because, and I think if you've seen a lot of the Aspire stuff and like the like the service defaults section that it adds to it, like it looks like it just makes it super easy that like with one line of code, I can see everything that happens within that pipeline of, I'm starting here, I'm going here, and like these are all of the different components that kind of make up like a request or a service call or whatever.
Yeah, absolutely.
But I did have one question I wanted to ask you about that. So you do have the observability stuff, and I saw that you have some resiliency stuff in there too. With I think you have like a chaos package or something like that. Like I don't know if you were going to talk about that. Could you say something about that really quick?
Oh yeah, absolutely. That is something that mainly I've used to test the resiliency features. Meaning, I needed a way to create some chaos, so database exceptions or problems, slowdowns in the distributed cache or the backplane. But I needed to do that in a controlled way. So what is commonly known as chaos engineering. This is like a lightweight version. So what I did is I implemented the chaos version, the controlled chaos version of the FusionCache components that I created. So like the backplane and the serializer or whatever, plus one for the distributed cache and something like that. Basically, it's like an adapter. You can give it the real one, and then it adds some chaos, and you can specify a probability to throw, so you can make it throw sometimes, but sometimes not. You can say always throw, or maybe you can say always delay between these and these values and stuff like that. I use that a lot in the tests because it's there are a lot more than I think 500 tests in FusionCache. You can look it up, and I use there to test everything is working. But I needed to control the chaos, otherwise there's no way to make tests in a reliable way. So yeah, that's that.
And Rescue was asking what program is that UI screenshot from? Which one of these?
This is Honeycomb.io. And by the way, thanks to Martin Tautz, I think I pronounced it correctly because he is one of the developers there, and he helped me in some of his free time because he's an expert on OpenTelemetry for .NET. He contributes to the open specification for .NET, etc. So he helped me a lot to understand some, caveats, some nuances in how to set up labels and stuff, how to check for the cardinality of the labels and some complicated
Maybe
stuff.
Let's try to have him on the show.
Yeah, so I will suggest that. I will absolutely suggest that. He's very nice fella, and it's been very helpful, and he knows a lot more than me about telemetry.
Yeah, we did have another question that was asked a while ago, and we were kind of waiting for an opportune time.
Yeah.
I think it makes sense now just to get into it. So a viewer from Twitch is asking if it's possible through FusionCache to introduce another caching layer for data that's not quite as hot, like, think S3 or blob storage.
The answer is yes and no, meaning from a pragmatic perspective, I thought about that. The usual thing is, why have a second level? Why not have like multiple levels? But actually, that is way more complex to handle in an intelligent way inside of FusionCache. So I took a pragmatic approach and I said, okay, just one level. Having said that, is just any implementation, as I said, of distributed cache. So what people can do, and I do that in an experiment that I have not published because it was just an experiment, you can implement your own distributed cache that takes an input to distributed caches and do the same thing for both. And you can do them sequentially, in parallel, however you want.
Aggregates them. Okay.
Yeah, absolutely.
So it's if through your APIs though specifically, there's no way for you to chain multiple layers in a sequence. It's just like you can add distributed caching, period, and then from there you have to write your own custom implementation that aggregates it.
Yeah, because again, the problem is that with a lot of features in FusionCache, you can control what happens when the distributed cache fails, for example. But if you have 2 or 3 fails, what it means, only 1, 2 of them, more than a half, it becomes too complicated for the 99.9% of the cases. So if you are into the 0.1%, implement your own. It's like, I think 6 methods or something like that, and just route the calls to the other ones. You want to do in parallel, in sequence, or you want to fail when one fails, when both. It's up to you. It's awesome. Quite simple as implementation.
Great.
All cool, all good, and we have a visual of the thanks to OpenTelemetry and all is cool, but sometimes still it's complicated stuff, honestly. I mean, I'm working on this from years, and still I would like to see something like for real while it is happening. Of course, this is very hard in a production system because volumes and stuff. So what I needed to do was seeing, for example, for the auto recovery feature, if something was actually working without having to crawl through logs and analyze them. So what I came up with is the simulator, and we'll see them in a second. Basically, is a small application inside of the source code of FusionCache. It's a separate project, of course, that you can spin up and you can simulate clusters, multiple clusters of multiple nodes, and try to see, okay, simulate the distributed cache fail, simulate the backplane fail, simulate the database fail, and you can see what happens. And so it's demo time, and I will briefly show you something. So do you see Visual Studio? Yeah, okay.
Yep.
So this is source code, the solution, and here you can find this simulator project. You can simply set a startup and run it. Now, there are some options you can play with if you want to try, I don't know, memory or Redis or, you know, different software timeouts and failsafe and whatever, but let's just run it as it is.
And first, whenever you get a second, would you mind bumping up that font size?
Yeah, I was about to do that. Yeah, okay. It's okay like this?
On the terminal, it's fine. But when you go back to Visual Studio, whenever you guys.
Yeah, sure, absolutely. Okay. So, okay. How many clusters? Let's do a simple one. One cluster with like 4 nodes. And do you want failsafe? Yes, why not? Okay. So this is a simulator. By pressing 1, I'm updating a random node on the cluster. Okay, the first cluster is the only one. So I press 1, and you see updates. And when it's green, all is good, all is aligned. Now, this is already cool. I mean, because this is your production environment in theory. This is simulated, but in theory, it's that. And you can see that when something updates, all the nodes are immediately updated thanks to the backplane. Now, we can simulate by pressing D, the distributed cache going off. And when we do an update, we'll see node 4 has been updated, but the others don't know. Why? Well, because the distributed cache is down. Then I can do disable also the backplane, re-enable the distributed cache, and do another update. Again, same node, another node, all is disaligned. If I re-enable the backplane, wait a couple of seconds, and auto recovery will immediately realign everything. Now that we see this, I would like to do up the ante a little bit. Here, I zoom the font, but there's not a lot to see here. I will run it again, but this time, let's simulate 4 clusters of 20 nodes each with failsafe. Now, I will zoom in a little bit. Let me see if I can. Okay, so what we are simulating here are 4 different clusters with 4 different distributed caches and backplanes. So imagine Redis instances. And each cluster has 20 nodes. So we're simulating 80 nodes, okay? Now, I can update each cluster by pressing 1, 2, 3, 4, and all is good. Now, bear with me for a moment. I will go quick because there's the cache duration that will kick in otherwise. So some updates, cool. I disable the distributed cache. 1 update on the first cluster. 2, 3 updates on the second cluster. I also disabled the backplane, so both are down. I update the third cluster, a couple of updates. I will re-enable the distributed cache, but backplane is still off. I will update the fourth. Now I re-enable the backplane, wait a couple of seconds, and auto recovery kicks in, and everything is aligned again, automatic. I have to say that having been through this in production systems without Fusion Cache and without auto recovery, these went bananas because, oh my God, things is unaligned. Why the hell this web node is returning 1 and the other is returning 2? It's rough. It's rough. And when it happens in production system, it's complicated to understand what is going on and recover for that. Auto recovery does that automatically for you. It covers, I wouldn't say all the cases, but a lot of different use cases of missing updates and whatnot. And with the simulator, you can play with the values and options and see how it goes. So that's the presentation.
That's really, really cool. I mean, you did a demo. I gotta give you a shout out. That's really cool. I love the simulator aspect of it.
Thank
I love being able to visualize all the concepts. It's like bringing everything finally together, like, and seeing. I mean, that's really impressive.
Well yeah, and you can use. Thank you very much. Appreciate it. And you can also use, as I said, a real Redis instance, and you can by changing a line of code, you can go to a real database if you want. I use these all the time to test new heuristics, new logics for the auto recovery, because sometimes there's a new niche edge case that pops up, and okay, I should consider that too. And how can I know that it's working? This is the way. Otherwise, I have to crawl through logs, and it's really too much. So my presentation was almost over, and I will shut up because I know I've talked a lot. So FusionCache, this is it. This is the screen that I showed at the beginning. Right now, it should be a little bit clearer, I hope. So method calls, output values, memory cache, always there, distributed cache, backplane optional, so there are dash lines, the factory that goes to the database, and maybe some notifications. V1.0 is right around the corner. I released it yesterday. I like to use this space to announce that. I released it V1.0 preview 1, just to be on the safe side. And in a matter of, I think, 1 week or 2, I will finally release 1.0. And to close this off, let me tell you that just to be clear for people that is getting to know FusionCache right now, this does not mean that is about to be ready for production use. This has been used in production from like the beginning. It's like 3 years that is using in production. As I said, it has 3 million downloads, the packages. And I've saw it used in microservices architectures, in small websites, big websites, mobile application. One guy in the community told me about a mobile game done in .NET, multi-platform that used the FusionCache with a distributed second level, implemented with an implementation of iDistributed cache on top of SQLite, which was a super smart move, I have to say, because you don't need distributed, you need out of process, so that cold starts have the data available without going to the net. That's very cool. That's very cool usage. I haven't thought about. Yeah. So please, if you want, grab the preview one of the V1.0 and give me some time. This ideally is a sum of FusionCache. Your service without it and your service with it. It's a little bit marketing PR stunt, I know, but that's conveys the message easily. And in general, it helps when poop hit the fan, so to speak. Thanks everyone, and these are my contacts.
Yeah, this is great.
Oh,
And,
that was.
I'm sorry, Maira.
Cecil, no, go ahead.
No, I was just gonna say, you showed us so much, and as we were talking, I'm looking at your GitHub repo, and there's so many other features that you still have not talked about. Yeah. Like there's the name caching stuff that's in here, the logging, the async await stuff. There's plugins that you can write for FusionCache. Yeah. So I gotta say, like, this has to be the most feature-rich caching library I've probably ever seen.
I don't know. I hope just it serves well the users. Like every open source project I've used in my career has helped me. I hope this in turn will help somebody else. And for now, I have to say people are responding well. They're thanking me because it works well. Again, somebody told me, oh, 50% less database cost to our database. We are saving a lot of money. I'm translating in real time.
Yeah, absolutely. It's a verbatim. It's totally fine. Totally fine.
Yeah. Okay. Anyway, yeah. So I just hope really that something good came out of it for other people.
Sure.
And do you need any help with your open source project? Like, are you looking for contributions or like, I don't know, documentation or like what is?
Yes. So let me check here for a second. So here, support. Nothing. I get too many times from the open source community, and this is just my way to give it something back. So no support, no money, no nothing. If you wanna speak money, make a donation to a charity of your own or whatever you want, and just drop me a line to let me know. That's all. Instead, with contributions, yes, why not? I had some contributions in the past, both ideas for features. That's very important because I would like to cover more use cases, or help with some documentation or something. Even though it's already quite extensive to say, but yeah, why not? I mean, every help is welcome.
You'll be able to update now your README there, since your version now is 1.0. You will.
No, 1.0 preview 1 is a pre-release.
Preview 1. Oh, okay, almost there.
Yep. Yeah.
I love it. I think it's a really great idea because you alluded to this very early on, but historically, I've always been kind of like, should I use memory cache or should I use distributed cache? And it's like, well, why not fuse the best of both worlds together and then have, eliminate the Stampede concerns and expose both first-class instances for sync and async options. The auto recovery, the backplane, like that's amazing. Amazing job.
Yeah, another approach I saw sometimes, even recently, is that, I just use the memory-based implementation of iDistributed cache, which Microsoft provides. Is mostly for like either demos or tests, or because when you want to use that to be ready for when you need to scale out, but initially you just want memory. And yeah, that's potentially a solution, but the problem is that with that, you always pay the price, not of the network, because it's memory, but of deserialization and serialization every single time.
Right.
So we are stressing the garbage collector and whatnot. So this was my way to say, have a new, like, initially, honestly, I was like I was about to call the abstraction hybrid cache. But I thought maybe a little bit too pretentious to be like the third leg in the iMemory distributed. But yeah, basically that's what it is. It's an hybrid cache. It can be memory distributed both. Or both. Yeah. Awesome. I talk a lot. Sorry.
No, you're good. You're good.
That's fine.
It was awesome. Thank you so much, Jody, for joining and sharing your knowledge with us about caching. I'm still blown away by the library and how much it accomplishes. Awesome. So thank you for hanging out with us here. And so
thank you too.
We're wrapping up today's show. Thank you everyone for watching and tuning in. And we have other videos and other sessions still available at dot.net/live. And we're gonna be back in 2 weeks. Next week is a holiday for us here in the US. So we're gonna be back in 2 weeks. With Morten Nielsen. He's going to be talking about WinUI-X, a library to build great .NET apps with WinUI 3 apps with .NET. And so we're back in 2 weeks. So thank you, everyone, for watching. We'll see you next time.
Awesome.
Thank you.
Thank you, everyone.
Bye-bye. Thank you.
Take care.